Algebra 2, this is 12.4 and 12.5. And for right now, this is going to be the last section of the trimester for you. So this is the last part of Algebra 2A. So feel free to cheer if you wish. I will give you a second to do so. Okay, now, here's kind of what we're doing. We are looking at when do we multiply, when do we add probabilities, because we're starting to take probabilities, which was 12.2 and 12.3, and starting to figure out when and how I can put them together. So now, take a look at the problem here. You got two spinners. To find the probability of spinning a purple and then spinning a blue, you need to find the probabilities of both events occurring separately. Spinning a purple and spinning a blue are independent events because the spinner on the left has nothing to do with the spinner on the right. The spinner on the right has nothing to do with the spinner on the left. Like, it doesn't matter. This will have no effect on this. Right? This is called independent. One does not affect each other. So the probability of getting a purple is going to be 1 out of 6. Probability of getting a blue is going to be 3 out of 4. So now to find the probabilities of spinning a purple and then a blue, anytime you see the word and, or you can think about and, you're going to multiply these two. So the probability of getting both of those is going to be 1/8. So probability of purple, like I said before, 1/6. Probability of blue, 3/4. Probability of both of those things are happening is going to be 1/6 times 3/4. 3 out of 24. 1 out of 8. So, Matt, kind of the general form is this. Probability of A and B occurring is just a probability of A times the probability of B. So, mutually exclusive says if I'm going to add the two things, because that's what I'm going to do. Mutually exclusive means or. All right, mutually exclusive says I can do this or I can do this. Mutually exclusive also means it cannot be part of both categories. Okay, so when I say mutually exclusive, it's two things that cannot happen at the same time. So drawing an ace or drawing a 2 from a standard deck of cards. Cards cannot be both an ace and a 2. Those are two different cards, so they are different. So when you say mutually exclusive and you're figuring out probability, you're trying to add. And the big idea here is whenever you see or, that's what you're going to add. So and means multiply, or means plus. So purple is going to be 1/6. Blue is going to be 3/4. So probably getting purple or blue is 1/6 plus 3/4. And here is where you need to test your fraction game and see if your fraction game is strong. So the probability of getting a purple or a blue is going to be 11 out of 12. So independent events. You have independent, you have dependent, you have inclusive, and mutually exclusive. So independent. Julio reaches into an ice-filled cooler containing 5 soft drinks and 5 diet soft drinks, removes the can, then decides he's not thirsty and puts it back. What's the probability that Julio and the next person to reach in the cooler both randomly select a regular soft drink? So here's kind of the part that jumps out at me, is that he puts it back. Not because, you know, I've never picked up a soda and not drank it and actually put it back. Unless I got yelled at, but that was, you know, totally different reason. He puts it back. When he puts it back, it's kind of like Julio was never there in the first place to get anything. All right, it doesn't affect anything. So what's the probability that he gets a regular soft drink and the next person gets a regular soft drink? So you want the probability of 2 regulars. So 1 and 1. So and comes into play here. So that means multiplication. So probably that Julio selects a regular soft drink is going to be 8 out of 13. But the probability that the second one also gets a regular, because he put it back, is also going to be 8 out of 13. So probability of both of them together getting both soft drinks is just going to be 64 out of 169. So 64 out of 169. That's your probability. So independent events. In a state lottery game, each of the 3 cages contains 10 balls. The balls are each labeled with the digits 0 through 9. What's the probability that the first 2 balls drawn will be even and that the third will be prime? So here's kind of what you're looking at. You're looking at 3 situations. You're looking at each cage kind of individually. But all right, the first one has to happen. The first one's got to be even. and the second one's got to be even, and the third one's got to be prime. So this has to happen, and this has to happen, and this has to happen, so you're going to multiply it. So even, we're going to count 0 as an even number, even though there's an argument about whether or not you do. So it's going to be 5 out of 10, 5 out of 10. Prime numbers, remember, prime just means can only be divided by itself and 1. So 1, 2, 3, 5, and 7. So even then, that's also going to be 5 out of 10. So basically, it's 1/2, 1/2, 1/2. So the probability of getting 2 evens and a prime is going to be 1/8. So mutually exclusive, 1 teacher must be chosen to supervise the senior class fundraiser. 12 math teachers, 9 language arts teachers, 8 social studies teachers, 10 science teachers. Teacher is chosen at random. What's the probability that the teacher is either a language arts teacher or a social studies teacher? Or means plus. You cannot be a math teacher and a language arts teacher. You cannot be a social studies teacher and a science teacher. Sometimes you can in real life, but this is the problem, so we'll just go with the problem. So 12, 8 is 20, 30. So there's 39 teachers total. So it's probably that you are a language arts teacher or a social studies teacher. So language arts is going to be 9. Social studies is going to be 8. And quite simply, you're just going to add them. So the probability of you getting language arts or social studies is going to be 17 out of 39, which is not quite 1/2. So 7 girls, 6 boys in the junior class homecoming committee. A subcommittee of 4 people is being chosen at random to decide the theme for the class float. It's probably that the subcommittee will have at least 2 girls. So this one's tricky because there's a couple different situations here. So you have to have at least 2 girls on the committee. Well, that means that you could have 2 girls, which would imply you have 2 boys. There is the situation where you could have 3 girls and 1 boy. Or there's a situation where you could have just all girls. So here's kind of my thing. I could have this, or this, or this. Or implies addition. So now how do I figure out the probability? Well, there's 13 people total, and 7 girls and 6 boys. So my denominator is here. Out of 14 people, I'm choosing 4. 14 people, choosing 4. 14 people, choosing 4. All right, each situation, I'm taking 4 people out of a total 14. Girls and boys is a little bit different. All right, now my numerator is going to be a little bit different. So I'm taking 2 girls out of 7 and multiplying that by 2 boys out of 6. So situation changed a little bit. Now for the middle one, I get 3 girls and 1 boy. The last one is just 4 girls. So you got to do a little bit of work with a calculator. And let's bring that up and take a look. First off, 14, choose 4 is going to be 1001. The numerators there are going to be this. Let's see, you're going to want, well, let's do the easy one first. 7, choose, go down, choose 4. This one's going to be 35. All right, then you're going to want 7, choose 3, times 6, choose 1. That's going to be 210. And then you got 7, choose 2, 6, choose 2. So last one, 7, choose, no, not you, 2, times parentheses 6. Choose 2. So that's going to be 315. So what you're going to have is this. Those three added together, 315, 210, and 35. So 315 and 210, that's going to be 525 plus that, that's going to be 560 out of 1,001. So a little bit more than a half a chance you're going to have that situation. Suppose, so inclusive, you can be part of both categories here. So inclusive means you can be both. So suppose you have 1,400 students, 550 take Spanish, 700 take bio, 400 take Spanish and bio. What's the probability that a student selected at random takes Spanish or biology? So mathematically, here's what we're looking at. So Spanish or biology, so you got to take the probability of Spanish or bio. All right, or means plus. But the problem is that you can take both. You can be part of both categories. So probability of Spanish is going to be 550 out of 1,400. Probability of bio is going to be 700 out of 1,450 or 1,400. But there's a group of people that were counted twice, or a group of people that were counted in both Spanish and bio. So you've got to subtract them once. You want them to be counted, but it's like you counted them in Spanish, so you're taking them away in bio. So when you do that, 550 plus 700 is 1,250. 1,250 minus 400 is going to be 850. So that's going to be 850 over 1,400, which a little bit of division. 240. I get a probability of 17 over 28. All right, so dependent. Whenever you see the term without replacement, that changes things. Okay, without replacement means what's the probability of a second thing given the first thing already happened. So mathematically, it kind of looks like this. So it's probably drawing a heart, heart, and a spade. So you have to draw a heart and another heart and a spade, just like that. I can't draw a spade, so I'll just put SP for spade. So probability of a heart's easy, 13 out of 52. Fancy way of saying 1/4. And implies multiplication. Now it's not 1/4 times 1/4 because I already took one heart out, so I've got 12 hearts left out of 51 cards. So now I've got my two hearts. What's the probability I got to get a spade now? Well, there's 13 spades left, but there's only 50 cards. So I want to multiply all those together. So I want to take 1 divided by 4. Oop, let's do this. 1 divided by, come on, do it. There we go. There you go. 1 divided by 4 times 12 divided by 51 times 13 divided by, not 3, times 13 divided by 50. And let's see if I can give it to me in a fraction. It does, 13 out of 850. So there's a probability of me doing all that. So 2,400 subscribers to an internet service. 1,200 own brand A, 500 own brand B, 100 both A and B was probably that you get one or you get brand A or brand B. Or there's addition. We know that already. So, but you got people that have both of these things. So that means they're going to get counted twice. So 1,200 out of 2,400 own brand A. Okay, 500 out of 2,400 own brand B. But you counted 100 of these guys twice, so you got to take one of them away. So 1,200, 500, 1,700 minus 100, 1,600. So you got 1,600 people who own either brand A or brand B. A little simplifying, 16 out of 24. Divide both top and bottom by 8. 2/3 of people own either brand A or brand B. All right, did I skip one? 3 cards, same suit without replacement. So 3 cards in the same suit. So basically, here's kind of what I would do. The first one can be anything, can it? So the first one's just going to be like 52 out of 52. All right, you're not picking a card. So now you're not picking your suit. You don't care if it's hearts, clubs, suits, or hearts, clubs, spades, diamonds. It doesn't matter. You pick your first card. It is what it is. So then after that, though, there's only 12 remaining of that suit. And then if you take one more, there's only 11 remaining. All right, so this is like pick a card, any card. And then once I do that, I'm locked in to that suit. So that's what that one would look like. So this is a big fancy way of saying 1. All right, so what you want to do is multiply those together. So 12 out of 51 times 11 divided by 50. Math. Fuck. What did it give me? 22 out of 425 will be your answer. That will be my probability. All right, I believe that's it. All right, take your time, watch over this video once or twice, and make sure you know what you're doing. But you got to think about the situation before you try and put anything together. Come talk to me with questions, and have a lovely day.